Students, let us see the next question here. Find the ratio in which xz plane divides the line joining the points a 1 comma 2 comma 7 and b 2 comma 3 comma minus 3. That is the question. Okay, this is the important question. Listen here. Find the ratio in which xz plane divides the line joining the point a and b is the question. So let us assume the ratio is m is to n. There is a point here. The point name is 1 comma 2 comma 7. Means these 2 points are in the space. Okay, another point is b is here. That is 2 comma 3 comma minus 3. These are in space. So these line joining these 2 points. Okay. So this will be vector, that is later we will discuss. So the ratio in which xz plane divides the line joining the points. So xz plane, one plane is dividing this, one plane. The plane name is xz plane. Okay, xz plane is dividing this in the ratio m is to n. Okay, m is to n. The plane is cutting this. Okay, this line plane is cutting this one in the ratio m is to n. Then is asking what ratio it is cuts. Okay, that's what you have to find here. The ratio is m is to n. So you know that point is here. Dividing point is, this is the point, you take it, the point is, this is a plane, it's cutting like this. Okay, so let the point p is equal to mx2, m into this 2m, mx2 plus nx1, that is n upon m plus n comma, okay, my2, that is 3m plus ny1, that is 2n divided by m plus n comma mz2, that is minus 3m minus 3m plus nz1 that is 3 into that is n into 7 into n, 7n divided by m plus n. This is what the point which is dividing this plane. This is the point, this is the plane which is dividing that line at this point. So now he is saying xz plane is dividing means y is equal to 0. That is the concept you have to take. So y value you take it 0. Xz plane, he said as xz plane, right? Is what he said here, xz plane. So xz plane is y you have to take 0. So if I take y 0, 3m plus 2n divided by m plus n is equal to 0. So what I get here, 3m plus 2n is equal to 0. I think it is xz plane or yz plane. I just need to check it. Okay, however, if it is xz plane, so what I get, y is equal to 0. Actually, it should be xy plane. Okay, fine. However, it may be xz plane. So m plus n is equal to 0. So 3m is equal to minus 2n. Then m by n is equal to minus 2 by 3. So 2 is to 3, externally it is dividing. The meaning of minus means externally. Let me check once question. Yeah, the question was xy plane. Okay, xz plane means I took y is equal to 0. In that case, that is the plane is dividing externally. 2 is to 3 externally. So I can write as m is to n is equal to 2 is to 3. Externally it is dividing. Okay, externally it is dividing. But if it is xy plane, then z will be 0. Minus 3m plus 7n divided by m plus n is equal to 0. That means that I am going to get here what, the m plus n 0 minus 3m plus 7n is equal to 0. So if I send m that side, I am going to get 7n is equal to 3m. This will become positive. So m by n I need, m by n. So n send this side, 3 send this side. M by n is equal to 7 by 3. Okay, m by n is equal to this, here you send this here, 7 by 3. Therefore 7 by 3, 7 is to 3, internally it is dividing. Hope you understand. Let us go for next concept. Yeah, let us start the next concept, that is direction cosines and direction ratios of a line. And this is most important concept of JEE. Okay, also in class 12th it is most important topic for class 12th. Right now it is class 12th topic. The direction cosines and direction ratios of a line. What is this here? Yes, here you have x-axis, you have y-axis, you have z-axis. Just we are taking x-axis, y-axis and z-axis. If you take a vector, if I take a line OP and this is called as OP vector. Okay, so this is a vector. If I take a vector in the space, that is Px comma y comma z, this line, this vector line, this line means vector. Actually in the space, if you are saying a line, that is known as a vector. Okay, so here this is a vector, makes an angle with x-axis. So with x-axis it makes an angle, with y-axis it makes an angle, with x-axis here makes, with y-axis here makes, with z-axis here makes. When these angles are made, okay, by this line, these are the lines. See here, direction angles, alpha with x-axis, alpha is the angle made with x-axis, beta with y-axis, gamma with z-axis. Then cos alpha, cos beta, cos gamma are called direction cosines. Okay, cos alpha, cos beta, cos gamma, these are called as direction cosines of the directed line. Means for this line, for this direction, if it is directed upper side, if this direction, see this direction is upper side, so then cos alpha, cos beta, cos gamma are the direction cosines. They are called direction cosines. Okay, then if the direction of a line is reverse, suppose if it is reverse, if the direction is not in this way, if the direction is opposite direction, if the direction is in this way, then the angle will be made by them is pi minus alpha, pi minus beta, pi minus gamma. With x-axis they make pi minus alpha, with y-axis they make pi minus beta, with z-axis they make pi minus gamma. So cos pi minus alpha, that is minus cos alpha, cos pi minus beta, that is minus cos beta, cos pi minus gamma, that is minus cos gamma. So that is the reason when the direction of a line is reverse, then we can say the direction cosines are minus cos alpha, minus cos beta, minus cos gamma are the direction cosines of this. So you understood what is direction cosines? So actually if a line, this is a directed line which makes an angle with x-axis, y-axis, z-axis, let us take alpha, beta, gamma, then cos alpha, cos beta, cos gamma is called as direction cosines. If it is directed this side, then cos alpha, cos beta, cos gamma. If it is direction opposite side, then this will be minus cos alpha, minus cos beta, minus cos gamma. Now there will be a unique directed cosines. Unique directed cosines means if it is direction line, directed line is there, so if it is fixed, then that is called unique directed cosines, and that is denoted by L comma M comma N. It means that L, M, N can be cos alpha, cos beta, cos gamma. That is only cos alpha, cos beta, cos gamma. Okay, they are directed. Okay, so it is a directed line. It's a directed, unique directed cosine denoted by, unique directed cosines are denoted by L comma M comma N. Are you understand? So L is equal to what? Plus or minus cos alpha, M is equal to plus or minus cos beta, N is equal to plus or minus cos gamma. Okay, hope you understand this. Hello dear students, now you have here, let us take, this is a coordinate axis x, y, z. Suppose if the line is not passing through the origin, we think that one line is there in the space which is not passing through the origin. Previous we have learned it is passing through the origin, then we have find direction cosines and direction ratios. Direction cosines are cos alpha, cos beta, cos gamma. Direction ratios are, what is direction ratio? I will tell you now. Now what is here, if it is xyz plane, if a line is not passing through the origin, if the line is not passing through the origin, then it will be passing somewhere in the space. So what you do here, for that line you just draw a line which is parallel and passing through the origin from this. So you can draw a line parallel to this. Okay, this is passing parallel to the origin. Okay, if it is a line is not passing through the origin, you can draw a line passing through the origin and parallel to that line. Okay, if then to find we draw a line. See here, if the line is not passing through the origin, then we draw a line to the origin and parallel to the given line. So for this given line parallel, we will draw a line passing through the origin. Then the parallel lines have the same direction cosines, means this L and this L dash means this parallel line and this given line and this parallel line have the same direction cosines, means these both will be have same direction cosines. Any three numbers, let us take any three numbers A, B, C, which are proportional to direction cosines L. So see, any three numbers you can take, the three numbers will be proportional to direction cosines. Let us take A, B, C are any three numbers. They will be proportional to direction cosines. So A is proportional to L, B is proportional to M, C is proportional to N. What I am saying here, any three numbers proportional to direction cosines a line are called direction ratios. So what are direction ratios? If you take any three numbers which are proportional to direction cosines, they are called direction ratios. If you take any three numbers, the three numbers which are proportional to direction cosines, they are called direction ratios. Means A is if I take A, B, C are three number, if A is proportional to N, B is proportional to M, C is proportional to N, then this A, B, C are called direction ratios. Like A is equal to lambda, proportional means what we'll write, A is equal to lambda times L, B is equal to lambda times M, C is equal to lambda times N, and this lambda should not be 0, that should keep in the brain. Okay, now what I can say here, direction ratios are A comma B comma C, then L, M, N are direction cosines of the line. Then L by A means these are proportional to each other. So L by A is equal to M by B is equal to N by C is a constant always. So the L value will be AK1, M value will be BK1, C value, N value will be CK. See here, L by A is equal to K, so L is equal to AK. See, L by A is equal to K, sorry, L by A is equal to K, then L is equal to AK, M by B is equal to K, then M is equal to BK, N by C is equal to K, N is equal to CK. See here, I will explain what is L, M, N clearly. Wait. So L, M are direction cosines, and direction ratios are that which are proportional to direction cosines. Whatever the numbers, direction ratios are the numbers. Direction ratios are any three numbers which are proportional to direction cosines. Which are proportional to direction cosines, they called as direction ratios. Now LMN, you know, direction cosines means what are there, you have already known that. So here, so L is equal to AK time, L is equal to AK, M is equal to BK, N is equal to CK, and L square plus M square plus N square is equal to 1. Squares of the direction cosines is 1. I will give the proof in the next lecture. Now I am going to give the proof. L square plus M square plus N square is equal to 1. Then L value can be substituted AK whole square, M value will be BK whole square, N value will be CK whole square. So if I substitute here, I will get K square common out, A square plus B square plus C square is equal to 1. Then K value will be what? What will be the K value? After substituting in this, K value will be, I am going to get K square is equal to 1 upon A square plus B square plus C square. Then K value will be plus or minus 1 upon under root of A square plus B square plus C square. This is the value of K. Okay, therefore the direction ratios are A is equal to. So you can see that what I am going to get here, the direction ratios are, direction ratios are, we can write by this. Okay, hope you understand. I have understood that L is equal to AK, M is equal to BK, N is equal to CK. We had this one. So L value will become what? L is equal to what you get here? AK, A into K, that is I get as plus or minus A by under root of A square plus B square plus C square. If they given any three numbers, then direction ratios to find, direction cosines to find, this is the formula. So L is equal to plus or minus a upon under root of a square plus b square plus c square, and m is equal to plus or minus b upon under root of a square plus b square plus c square, and n is equal to c upon plus or minus c upon under root of a square plus b square plus c square. So this is what you get. L value is plus or minus a upon square root of a square plus b square plus c square. M is equal to plus or minus b upon under root of a square plus b square plus c square. N is equal to plus or minus c upon under root of a square plus b square plus c square. These are called direction cosines. See here, I'll just say simply a, b, c are three numbers. Then their direction cosines will be L is equal to plus or minus a upon under root of a square plus b square. M is equal to plus or minus b upon under root of a square plus b square plus c square. N is equal to plus or minus c upon under root of a square plus b square plus c square. This is what we called as direction cosines. Okay. For any line and direction ratios are like you have a line. So for that direction ratios are a, b, c. Then ka, kb, kc also direction ratios. It means for any line infinite direction ratios are possible. Like if you have a, b, c, then I can multiply a with k, any number, ka, kb, kc. K can be any real number, so any number can be that. So there will be have infinite direction ratios for any line. Okay, for any line there will be infinite direction ratios. And here you should understand is direction ratios is denoted by dr S and direction cosines are denoted by drcs. So I'll give you more detail in the next lecture. Just see here. See, I made you understand that what is direction ratios and what is direction cosines. But I just want to prove this one. I just proved yesterday, previous lecture, L square plus m square plus n square is equal to 1 I took. That how you got, I will explain. See here, this is the space. Okay, this is you have a 3D. This is the point in the space p x comma y comma z, and just we are taking here x axis, y axis, and z axis, and this x axis will make angle with x axis, y axis, and z axis. Let us x axis is alpha, y axis is beta, and z axis is gamma. Okay, so you took here x, y, z. So these we have taken. So here what I want to say here, the perpendicular distance of this p on this a. So this distance is x1. So this here to here the distance is x1 because the point is traveled to OA. The OA distance is x1 distance it is traveled. So OA is x1 distance. This p is in the space. Okay. So OA is x1 distance. And this is, you know, already it is a perpendicular. Already I told you this is a perpendicular. So it is on the x-axis. X-axis means that is x1 comma 0 comma 0. It's a perpendicular, means this is makes 90 degrees. So it is a right angle triangle. Just see, this is a right angle triangle. If this is a right angle triangle, then this is x1, this is r, it is a right angle triangle, this is a hypotenuse. This is hypotenuse. Right angle opposite to hypotenuse. So what I can use is here cos alpha. See, x1 is equal to r cos alpha. I can use right angle triangle rule. Using the right angle triangle rule, according to this angle, I can say that x1 is equal to cos alpha. Okay, x1 is equal to cos alpha. Cos alpha. Why x1 is equal to cos alpha? Cos alpha is equal to x1 by r. Cos alpha is equal to x1 by r adjacent by hypotenuse. So x1 is equal to r cos alpha, y1 is equal to r cos beta, z1 is equal to r cos gamma. R is what? R is the distance from origin to this point. So this is the distance. R is the vector. You suppose OP is a vector. That vector is R. You can take R is the distance. You can take OP distance. So R is equal to that. So then I told L square plus m square plus n square is how much? That is L square plus m square plus n square. I told you L, m and r making the angles with this. So they are called cos alpha, cos beta, cos gamma. So I can write as cos square alpha plus cos square beta plus cos square gamma. I told you just now. L, m and r direction cosines. L is cos alpha, m is cos beta, n is cos gamma, right? So this value is how much is that? So if you find this one, cos alpha value is x1 by r whole square. Okay, cos beta will be what here? Cos beta will be y1 by r whole square. Cos gamma will be z1 by r whole square. It means this is, I am going to get x1 square by r square plus y1 square by r square plus z1 square by r square. It means I am getting this value will be x1 square plus y1 square plus z1 square by r square. What is r? Distance of this under root of x1 square plus y1 square plus z1 square. The distance of this is r. So here r square means what I get? X1 square plus y1 square plus z1 square, divide by square root cancel. So x1 square plus y1 square plus y1 square plus z1 square. This is cancel. Answer I got 1. So L square plus n square is equal to 1. That is what I used for direction ratios. So one thing you remember in this entire concept, one thing you have to remember, direction cosines are angles which made, means a vector line, a equation of a line which is passing through the origin, a line which is passing through the origin, making the angle with x-axis, y-axis, z-axis, they are called direction cosines, and they are called cos alpha, cos beta, cos gamma, and these are denoted by LMN. Okay, and one more thing is, if any line parallel to, which is one line is parallel to origin, but it is not passing through the origin. If this is not one line is there in the space, but it is not passing through the origin, at that time we will use what? Direction ratios. What we use here? Direction ratios. We will draw a line parallel to that, and we will write the proportional things. Means this is this many times of that. Means if it is two lines are parallel, what I want to say here, you have learned in the vectors. If two lines are parallel, this vector is parallel to this, means this vector can be expressed some lambda times this vector, right? So this vector means these are expressed some lambda times. Okay, so that is the reason they are called direction ratios. So directions ratios are nothing but, you understood that, nothing but what here? They are they are proportional to direction cosines. Direction ratios are proportional to direction cosines because they are parallel in the space, vector concept according to that. So here you understood what is direction ratios. If A, B, C are three numbers, okay, they are direction ratios, then direction cosines will be what? L is equal to plus or minus a upon under root of a square plus b square plus c square. M is equal to plus or minus b upon under root of a square plus b square plus c square. N is equal to plus or minus a upon under root of a square plus b square plus c square. A upon L is equal to a upon square root of a square plus b square plus c square, plus or minus M is equal to plus or minus b upon under square root of a square plus b square plus c square, and N is equal to plus or minus c upon a square root of a square plus b square plus c square. They are the direction cosines if A, B, C are direction ratios. If A, B, C are any three numbers, then direction cosines are that. Okay, that how you proved? I used the L square plus M square plus N square is equal to 1 concept. I proved that already. So here, this concept to understand, you can, if you please watch twice this concept, watch my video twice, then you will understand this concept. Direction ratios and direction cosines are very important concept, and if you understand this, and you can do problems very easily. Hope you understand. Let us see next.